So we've already been finding the area between two curves in terms of x. And in this video, we're going to take a look at an example of when finding the area between two curves would be easier and more convenient in terms of y. All right, so let's take a look at this particular problem and notice that in this problem that the functions are given in terms of y. They're not even given in terms of x. We have a g of y function and an f of y function. So the first thing I'm going to want to do is to take a look at those equations graphically to see what's going on here. And even though we're going to do the problem in terms of y, I'm actually going to change it back in terms of x for easy graphing. So that means I'm going to solve each equation for y. So I'll have x equal to 3 minus y squared, which is x minus 3 is equal to negative y squared. I'm going to divide both sides by negative 1 and change the order. So all I did there is divide both sides by negative 1, take the square root of both sides with a plus and a minus, don't forget about that. And that tells me that I have a sideways, hopefully you remember that initially from your Algebra 2, I have a sideways parabola, and it opens to the left because the coefficient of y squared is negative 1. And then for the other equation, I have x is equal to y plus 1. So if I solve for y, I get y equal to x minus 1. So that's just a line. Now again, the reason that I did this was for graphing purposes, so I can see what this thing looks like. So I'm going to start out with graphing the sideways parabola. If I let x be, if you're concerned, you can make a little t-table. If I let x equal to 3, I get the vertex of the parabola, and as we already said, it opens to the left. But if you're in doubt, you can plot a few more points, and you'll see that if you substitute a number greater than 3, you'll get a negative under the radical, sending you back in the other direction. And then the line has a y-intercept of negative 1 with a rise 1 and a run of 1. So the graph looks something like this. Now the reason that I'm going to go in terms of y instead of in terms of x, notice I have my point of intersection number 1, and I have my point of intersection number 2. And if I go in terms of x and I sweep the area from left to right, everything is fine until I get to here. Because from between those 2 point of intersections, the blue line is the top curve, and the red bottom half of the parabola is the bottom curve, but when I get to the second point of intersection, I've still got some area that I'm going to have to go back and accumulate, and I'm going to have to do the top curve as the top half of the parabola, and the bottom curve as the bottom half of the parabola, which is probably already making you a little bit nervous. Here, I'm just going to give myself a little more space to work here. So I'm going to deal with the problem in terms of y, because instead of being a clear top curve and a clear bottom curve, there's a clear right-hand curve and a clear left-hand curve. Now what we were doing before when we were in terms of x, we were going from the lower bound point of intersection to the upper bound point of intersection, and we were doing the top curve minus the bottom curve in terms of x. Well, we're going to follow the same pattern. It's really not that different, except for instead of our lower bound being on the left, our lower bound is going to be the lower y value point of intersection to the upper y value point of intersection. And instead of doing a top curve, we're going to do the right-hand curve in terms of y minus the left-hand curve in terms of y. So in this problem, notice that the parabola is on the right-hand side all the time, and that the line is the left-hand side, the left-hand side all the time. I still have to find the point of intersection, just like I did in terms of x. So I'm going to set the two equations equal to each other in terms of y. So I have 3 minus y squared equal to y plus 1. I'm going to set that equal to 0, and I'm going to add y squared to both sides, subtract 3, and I get negative 2. I'm going to factor a y and a y and a 2 and a 1 and a plus and a minus. So I get y equal to negative 2, y equal to 1. Negative 2 is lower bound, 1 is the upper bound. So I know that this y value is negative 2, this y value is 1, so I'm going to accumulate the area from a low y value of negative 2 to a high y value of 1. Right-hand curve, it's always tempting to do the left-hand curve. It's the right-hand curve, and the right-hand curve is the parabola in terms of y, which is 3 minus y squared, minus the left-hand curve in terms of y, which is the line, and make sure that you put a parenthesis behind that subtraction so that you don't make a silly mistake. I'm going to clean this up and make this negative y squared minus y. I'm just simplifying. 3 minus 1 is 2. And again, bear in mind that we're in terms of y. When I find the antiderivative, I'll get negative y cubed over 3 minus y squared over 2 plus 2y, evaluated from negative 2, be careful with my writing here, to 1. Alright, so I'm substituting 1 into the expression, so I get negative 1/3 minus 1/2 plus 2. That's substituting 1 into my antiderivative. And then substituting in 2, I'll get negative 8/3 minus 2 minus 4. All right, let's combine some like terms. I have a positive 2 plus 2 is 4 plus 4 is 8. Okay, so I've taken care of the 2, and the negative 2, and the negative 4, and I got a positive 8. I have a negative 1/3 plus 8/3 makes 9/3, which is 3. I just spotted a mistake. I'm glad I caught that right now. Let's go back to, you probably already caught this. When I substituted negative 2, that's what happens when you do work in your head. That's why I tell you not to do that. When I substituted negative 2 in here, I get negative 8/3 times the negative makes a positive 8/3. So let me just go back and fix that so that you're not confused. Sorry about that. Don't do work in your head. Show the work. All right, so substituting 1 again, I will get negative 1/3 minus 1/2 plus 2. Subtract the lower bound, substitute in negative 2, which gives me negative 8/3 times a negative is positive 8/3 minus 2 minus 4. So negative 2 squared. Okay, I think we're on a better track now. All right, combining like terms, I have a positive 2, a positive 2 making 4, and a positive 4 making 8. So gone, gone, gone. I have a negative 1/3 minus 8/3 makes negative 9/3, which is negative 3. So gone and gone. And then I have a minus 1/2, so I have 5 minus 1/2, which is 4 and 1/2, which is the area bound between those two curves. So this problem lent itself to be much more friendly. I know it probably doesn't feel friendly to you, but it was actually much more friendly to do this problem in terms of y. Doing it in terms of x would have been a much more tedious process. So review this video as needed, and that's area between two curves in terms of y.